Let's look at this question that are related to the calculation of expectation and variance. If you want to read through the details of this question, you may want to pause this video before you proceed to the solution. Okay, so now let's look at how to solve this particular question. For part A, we want to calculate the expected value and the variance of the daily miles driven by the customer. Basically, we want to calculate the expectation of X as well as the variance of X. To calculate the expectation of X, given that the PDF is already given, so we can just using the formula, the integration of X times fx dx. If you can't recall the formula, an easy trick for you to remember this formula is that you can always refer to the probability mass function that is related to a discrete random variable. Basically, it's the sum of x times px. So here, integration is nothing but the sum of infinity. So it's related to sum. Value of x is value of x. Fx times dx, actually you can think as, if this is dx, this is fx, it's nothing but the area and the curve. So basically it's the probability related to the discrete cases. So if you are familiar with the formula of the expectation, then it's quite easy to solve this problem. Then we can just substitute in the expectation of x is equal to the integration from 0 to 4, because the range of value is 0 to 4, and x fx dx. Then we can just substitute in the formula for fx and do the integration accordingly, and eventually you will find out the expectation of x is 2.5. And in order to calculate the variance, there's a very handy formula for us to calculate the variance of a particular random variable, which is the expectation of x squared minus the expectation of x squared. Since we already calculate the expectation of x, so it's quite easy to calculate the second terms. Then we just need to figure out what is the expectation of x squared. Then we can find the variance of x. So we just first calculate the expectation of x squared with the similar steps. Then we can just do the integration from 0 to 4 with the function x squared times fx dx. And then the integration part is similar to the first part, and then eventually we have found out the expectation of x squared is 7.2. And then we can just use the formula for calculation the variance. Variance x equals to the expectation of x squared minus the expectation of x to the power of 2. Then we just substitute in the values, and then we can get the variance of x is equal to 0.95. Okay, for part B, we want to find the expectation and variance of daily spending of customer. So we can denote this daily spending as S. Then based on the problem statement, is nothing but 2 times x, $2 per mile driven, and x mile is the distance. If we have this relationship, we can easily use the property of expectation to calculate the expectation of S based on the expectation of S. So let's see how we do it. So the expectation of S is nothing but the expectation of 2x. And we can bring the constant coefficient 2 outside the expectation. This is leveraging on the property of expectation. Expectation of ax plus b is equals to a expectation of x plus b. So in this particular scenario, b is 0 and a is 2. Hence, expectation of 2x is equal to 2 times expectation of x. Since expectation of x is already calculated as 2.5, then we just need to substitute in is 5. So similarly for variance, we can use the property of variance. Variance of ax is equals to a square variance of x. In this particular case, a is equal to 2. Hence, variance of 2x is equal to 4 times variance of x, basically is 3.8. Then we can look at the last part C. Part C, we want to determine how often the daily spending will exceed its expectation. So basically, we want to calculate the probability of x greater than expectation of x, which is 5. That is based on our previous calculations. And we know that x is equal to 2x. Hence, this is the same as to calculate the probability of x greater than 2.5. So maybe I write down, so it's basically equal to 2x greater than 5. Then divide the both inequality expression by 2. Then we get the probability of x greater than 2.5. So in order to calculate the probability of x greater than 2.5, if you still recall, if we given you a probability density function, you just need to find out x equal to 2.5, and the upper bound for x is 4. We just need to do the integration of this part to find out area and the curve. Then this is represent the probability that x is greater than 2.5. So we just do the integration from 2.5 to 4. And then once we've done the integration, we can find out the probability basically is 0.536. So this is one approach to calculate the probability directly based on the PDF. But we can also calculate the probability based on the CDF itself. Just recall a little bit. CDF A is equal to the probability of x is less equal to A. So if we have CDF F, calculate the CDF FA, then we can easily substitute arbitrary A values to calculate the probability of x that is less equal to A. And then if we want to calculate the probability of x is greater to a particular value A, then we can just use the complement rule. 1 minus the probability of x less equal to A, then is equal to 1 minus fxa. So this is another way that we can calculate the probability of x is greater to a particular value, that is leverage on the CDF. So in order to calculate the CDF, since the definition of CDF is that if A is equal to the probability of x less equal to A, we just need to do the integration. So probably let me just erase a little bit. So here, we can just simply calculate the integration. The probability of x is less equal to A basically is nothing but integrate area and the curve. So in this case, we are no longer integrate it. Maybe let me redraw it. So in order to calculate the if A is equal to the probability of x is less equal to A, what we need to do is that we need to do the integration from the lower bound is 0 and the upper bound is A for fx dx. Basically, for this particular calculation, what we did is that if let's say this is the PDF, what we are doing is that we are doing a calculation of area and the curve from 0 to A. And then we can just do the calculation accordingly to get a particular function of FA. And then we can easily calculate the probability of x greater than a certain numbers. So let's see how to do it. So first, we calculate the FA as what we mentioned just now, the probability of x less equal to A. Just do the integration from 0 to A. And then we can easily calculate the function of FA is this. And then we can easily substitute the value to calculate it. So we can leverage on the complement rule in order to calculate the probability of x greater than 2.5. Basically, is to calculate the probability of 1 minus the probability of x less or equal to 2.5. And then hence this is in the format of x is less equal to an arbitrary value. Then we can just substitute this value 2.5 into CDF here. And then we can get the same result, 0.536.